Express g of x equals 2x squared minus 8x plus 11 in standard form. Find the coordinates of its vertex and determine its maximum or minimum value. Let's rewrite the function down here so that we can go through the process of completing the square and putting it in standard form. First, we need to factor out the leading coefficient from the variable terms. So that's going to give us 2 times the quantity x squared minus 4x. And we leave the constant term on the outside. Then we need to complete the square. To do this, we take negative 4 divided by 2. That gives us negative 2, and square it. That gives us positive 4. So we add 4 inside the parentheses, but we're really adding 2 times 4, which is 8. So to balance out the function, we also need to subtract 8 so that we're not changing the value of the function through this process. Now we can factor this perfect square trinomial inside the parentheses. That's going to be x minus 2 quantity squared. And we can combine like terms. 11 minus 8 is 3. So g of x in standard form is 2 times the quantity x minus 2 squared plus 3. Now that we've got it in standard form, we can see what the vertex is going to be. Remember that the x-coordinate of the vertex, h, is the number that's being subtracted from x inside the parentheses. In this case, that's 2. And the y-coordinate of the vertex, k, is just the constant term. In this case, that is 3. And so our vertex is the point 2, 3. Now, to determine if we have a maximum or a minimum, notice that the leading coefficient here, 2, is positive. When we have an a value that's greater than 0, that means the parabola is opening upward and we have a minimum. So our minimum function value, remember it's the y-coordinate of the vertex. The minimum function value is 3, and it occurs when x is equal to 2. So we have found our minimum function value. You can plug in values for x all day long. You can make a table of values with 1,000 values in it, and you're never going to get anything that's less than 3 because that is the minimum possible function value for this function.